Today we use the Moore-Penrose pseudoinverse to solve least squares linear regression. And then compare that with the method based on QR decomposition. 2 methods, 1 answer, and naturally a chance for numerical drama. In linear regression, we want x beta to approximate y. Usually there is no exact solution, so we choose beta to minimize the length of x beta minus y. That is the least squares problem. Apparently reality once again refused to fit perfectly into a linear model. A least squares solution is characterized by an orthogonality condition. The residual y minus x beta hat must be perpendicular to the column space of x. Equivalently, x star times that residual is 0. This gives the normal equations. X star x beta hat equals x star y. The clean conceptual answer is beta hat equals x plus y. This always gives a least squares solution. Even better, if there are many least squares solutions, x plus y is the one with smallest norm. So the pseudoinverse gives a canonical choice instead of letting the solution wobble around ambiguously like a badly written committee report. If x has full column rank, then x star x is invertible, and the pseudoinverse has the familiar formula x plus equals x star x inverse times x star. So beta hat equals x star x inverse times x star y. Yes, the normal equations are back, because apparently they refuse to leave politely. Now compare this with the QR method. If x equals QR, with Q having orthonormal columns and R upper triangular, then minimizing norm x beta minus y is equivalent to minimizing norm R beta minus Q star y. If x has full column rank, R is invertible, so we simply solve R beta hat equals Q star y by back substitution. Much less melodramatic than forming x star x. When x has full column rank, the two methods give exactly the same answer. Since x equals QR, we get x star x equals R star R. A short calculation shows x plus equals R inverse Q star. Therefore beta hat equals R inverse Q star y. Exactly the same formula produced by the QR method. Different route, same destination, less chance to blame the algebra. So which method should we prefer? The pseudoinverse is the most general. It works even when x is rank deficient, and it gives the minimum norm least squares solution. The QR method is excellent when x has full column rank. It avoids forming x star x directly, and is usually more numerically stable than solving the normal equations head-on. In practice, QR is often the workhorse, while the pseudoinverse gives the broader conceptual picture. If x is rank deficient, then the least squares problem may have infinitely many solutions. The pseudoinverse still gives a unique answer, namely the minimum norm 1. A basic QR decomposition by itself does not package that canonical choice so cleanly. So once again the pseudoinverse gets to look smug. So the story is simple. Least squares linear regression can be written conceptually as beta hat equals x plus y. When x has full column rank, the QR method gives the same answer. Beta hat equals R inverse Q star y. The pseudoinverse is more general and canonical. QR is usually the practical and stable computational method. Everyone gets something they want. How uncharacteristically civilized.